Hello everyone, this is Ramachandran, math tutor from Online Math for All. In this video, we are going to see the general math topic that is probability. First, we will see what is probability and also the stuff we have to know to find the probability of an event. And apart from that, the other stuff in probability like random experiment, mutually exclusive events, exact events. So all those stuff we are going to discuss in detail with examples. Okay, let's go to the stuff. Okay, first let's look at the stuff for random experiment. Let me write the stuff over here. First, let's understand what is meant by random experiment. For example, I am tossing a coin. When I toss a coin, it will produce a certain results like a head or a tail. So when I toss a coin, it will be considered as an experiment. Then what is called random experiment? Okay, we know that when a coin is tossed, there are two possible outcomes. One is head and other one is tail. Can you say in advance what will be the outcome? No, we cannot. So we can predict, but we cannot say surely which one is going to be the outcome, that is head or tail. So the outcome is depending on by chance only. So that's called random experiment. So we know that the results of an experiment, that is a possible outcomes, but we will not be able to say surely what will be the exact outcome. So that kind of experiment is called random experiment. Okay, and also let me consider events. Okay, when I consider a random experiment like tossing a coin, it produces two possible outcomes, a head or tail. So if I consider only a head, that is getting the outcome head, it's called event. So event is a part of the results of an experiment. And when I consider getting tail, that is also an event. And not only tossing a coin, for example, let's consider rolling a die. We know that a die is in the shape of a cube like this, and we have 6 faces. So when I number the faces like 1, 2, 3, 4, 5, 6, I'll be getting 6 outcomes. I mean, the 6 possible outcomes are there, but the result will be one of these 6 numbers. Okay, I've listed out all the possible outcomes over here. So when I roll a die, I'll be getting one of these 6 numbers, and that will be called as an event. All together is called the sample space. So when experiment is done, when I list out all possible outcomes, it is called a sample space, and it will be mentioned as capital S. Okay, here for example, let us consider getting an even number. Then you will be getting 2, 4, 6. This is an event of getting an even number. So it's a part of the sample space. Okay, now let's consider mutually exclusive events. Let me consider tossing a coin. Then there are two possible outcomes, head and tail. So a set which contains all possible outcomes is called sample space. Already we have discussed. Okay, now in this sample space, let's consider getting the outcome head. Let A be the event of getting head and B be the event of getting tail. Okay, now when a coin is tossed once, if the coin turns up head, then there is no chance to get the tail. In case a coin turns up tail, there is no chance to get head. So if there is outcome head, then there is no possibility for the outcome tail. If there is outcome tail, then there is no possibility for the outcome head. So these two outcomes are called mutually exclusive. That is, the occurrence of one outcome will exclude the occurrence of the other outcome. That is, the occurrence of head will exclude the occurrence of tail, or the occurrence of tail will exclude the occurrence of head. So the same thing we can consider when a die is rolled. The sample space that we have discussed, it is a set of all possible outcomes, 1, 2, 3, 4, 5, 6. Okay, let capital X be the event of getting an even number, that is 2, 4, 6, and capital Y be the event of getting an odd number, 1, 3, 5. Okay, so when a die is rolled, if I get an even number as outcome, there is no chance for odd number. In case I get an odd number as an outcome, there is no chance for even number. So getting an even number and getting an odd number are called mutually exclusive events when a die is rolled, because the occurrence of one event will exclude the occurrence of the other event. Okay, so now let's discuss the exact events. For example, let's consider again tossing a coin. Let A be the event of getting head and let B be the event of getting tail. Now, let me combine these two sets A and B, that is A union B equals to what? So we have to write the elements of the set A, that is H, and now I have to write the elements of set B. In case if the element already appears over here, we should not write it, because in set, repetition of element is not allowed. Okay, here we have tail. Tail has not been written already. We can write over here. Okay, when I combine these two events A and B, that is equal to sample space. then we can say these two events A and B as as exhaustive outcomes. So whenever I combine two or more events, then it is equal to the sample space. We can say those events as exhaustive events. Okay, we can consider like another example, that is let's consider rolling a die. That is sample space is 1, 2, 3, 4, 5, 6. Let me consider event A of getting the number 1, 2, and B be the event of getting 3, 4, and C be the event of getting 5, 6. What if I combine all the three events over here? That must be equal to the sample space. Then we can say all these three events A, B, and C are exhaustive events. Okay, so these are the basic stuff we need to know before we start working on probability. Okay, now let's consider the formula to find a probability of an event. Let me write the stuff over here. Here we have the formula to get probability of an event. The formula is we have to write the total number of all possible outcomes of an experiment in denominator. In numerator, we have to write number of favorable outcomes. What is meant by number of favorable outcomes? To understand this, let's consider an example. That is, let me consider an experiment, that is tossing a coin. Then the sample space, a set which contains all possible outcomes, head, tail. Okay, so what is the total number of all possible outcomes in a coin is tossed? There are two possible outcomes. So we have to write this number 2 in denominator. That is the total number of all possible outcomes. Okay, let me assume I want to find the probability for getting head. Okay, then we can assign an event A for getting head. So now my aim is to get the probability for the event A, that is getting head when a coin is tossed. So let me write P of A, that is a probability of event A. Okay, in numerator, I have to write the number of outcomes where I am getting head. There is only one outcome I am getting head. So that one is called the number of favorable outcomes for getting head when a coin is tossed. So this 1 over 2 is the probability for getting head when a coin is tossed once. Okay, now let me assume another event B, that is B be the event of getting a tail. Then what is the probability of getting tail? That is a probability of the event B. So the same, that is 1 over 2. There are total number of possible outcomes is 2, and there is only one outcome where I am getting tail. Okay, here a coin is tossed once, and I got the probability of getting head, that is 1 over 2, and also I got the probability of getting tail, that is also 1 over 2. Okay, when a coin is tossed, the probability of getting head and the probability of getting tail are equal. Then we have to say that these two events are called equally likely events or equiprobable events. Whenever we have the same probability for two or more events, then we have to say those events as equally likely events or equiprobable events. That is, both the events have the same chance, equal chance to occur. Or we can write this one in percentage. Then you'll be getting 0.5 when I convert this one to decimal. And to convert this decimal to percentage, I have to multiply this value by 100. Then I'm getting 50%. And the same result I'll be getting for this one. That is 50%. When a coin is tossed, there is a 50% chance. Probability means that we measure the chance for an event to occur. So there is 50% chance for getting head. There is a 50% chance for getting tail. And also, when I find probability for any event, always the value of the probability will be between 1 and 0. So the value of probability of any event will never be greater than 1, will never be less than 0. In case you are getting probability of an event greater than 1 or less than 0, so there is something wrong with our work. Okay, so here let's consider in what situation we'll have a probability that is exactly equal to 1. If the probability of an event is equal to 1, then we have to say this is a sure event. Let me write over here. What if the probability of an event is equal to 0? Then we have to say that's called impossible event. Let me write over here. Okay, now let's understand what is sure event and what is impossible event. Now let me consider that is rolling a die. Then the sample space is going to be the numbers 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. That is the total number of all possible outcomes is 6. Okay, now let A be the event of getting a natural number from 1 to 6. How many outcomes are there? So a natural number from 1 to 6 is 1, 2, 3, 4, 5, 6. Now I want to find probability of the event A. So that is the event of getting a natural number from 1 to 6. Okay, we know that when a die is rolled, the total number of all possible outcomes is 6. And we are trying to find probability for the event A, where I'm getting a natural number from 1 to 6. How many outcomes are there for A? There are 6 outcomes. 6 over 6 is 1. So this is called sure event. That is, when a die is rolled once, the probability of getting a natural number from 1 to 6 is 1. And now let's consider in the same experiment, that is, a die is rolled once. Let A be the event of getting tail. Okay, so when a die is rolled, is there any chance to get head? Let me write over here. That is the probability of event A equals to the total number of all possible outcomes is 6. Okay, in these 6 outcomes, in how many outcomes do we have this outcome head? No, there is no outcome where we get head. So then the number of favorable outcomes is 0. Then 0 over 6 is 0. Because when a die is rolled, getting head is impossible event. So for that we have probability 0. So there is no chance at all for the event to occur. So hope you understand what is sure event and what is impossible event. Now let's look at the other stuff. That is the simple or elementary events. The second one is a composite or a compound events. Okay, let's understand what is a simple event. Let me consider the experiment. That is tossing a coin. Then the sample space is head, comma, tail. Now let me consider the event of getting one head. Okay, let me write H over here. Can I decompose this one into further events? No, I cannot decompose this one into further events. Whenever an event cannot be decomposed into further events, then it is called simple or elementary event. Let me consider another experiment, that is tossing a coin twice. A coin is tossed twice. Let me write the stuff over here. A coin is tossed twice. Now let me write all possible outcomes over here. That is the first time I may get head, the second time also I'm getting head. The first time I'm getting tail, the second time also I'm getting tail. First time I'm getting head, the second time I'm getting tail. The first time I'm getting tail, the second time I'm getting head. So there are 4 possible outcomes and a coin is tossed twice. Now let me consider the event of getting just one head. So here when I consider the event of getting one head, so here we have one outcome, here we have one outcome. My aim is to get only one head. Further it can be decomposed into 2 events, that is HD and TH. So here in this example, the event of getting one head can further be decomposed into 2 events. Then getting one head when a coin is tossed twice is a composite or compound events. Okay, so these are the basic stuff we have to know to do problems on probability. Now let's do some problems on probability. Here we have a problem. Let me go over the question. A coin is tossed 3 times. Find the probability of getting 2 heads, at least 2 heads. Okay, there are 2 parts in this question. The first part is we have to find the probability for getting 2 heads, and the second part is we have to get probability for at least 2 heads. Okay, first we have to write the total number of all possible outcomes, because already I have given you the formula to find probability of an event. There is number of favorable outcomes by the total number of all possible outcomes. Okay, when a coin is tossed once, we know that there are 2 possible outcomes. One is head and other one is tail. But here a coin is tossed 3 times. Then we have to take this 3 as exponent for 2. Then 2 to the third power is 8. So when a coin is tossed 3 times, there are 8 possible outcomes. The total number of all possible outcomes is 8 for this experiment. Okay, first we have to write the sample space which contains all possible outcomes. Okay, here I may get head in the first time, head in the second time, head in the third time, or tail in the first time, tail in the second time, tail in the third time, or head in the first time, head in the second time, and tail in the third time. That is, let me take this particular outcome. In this outcome, I am going to replace each h by t. So I just replace the last h by t, then I got the outcome hht. Now let me replace the middle h by t, then I'm getting hth. Now let me replace the first one by t, then I'm getting thh. Okay, now let me take this outcome. I'm going to replace each t by h, then I'm getting tth, then tht, then htt. Okay, now let's count the number of outcomes over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 possible outcomes. Now let's get the probability of getting exactly 2 heads. Let me assume this is event A. So probability of getting event A, that is exactly 2 heads, is going to be, first we have to write the total number of all possible outcomes in denominator, and for this event we have to write the number of outcomes in numerator, that is exactly 2 heads. Let's count the number of outcomes where we get exactly 2 heads. 1, 2, 3. There are 3 outcomes. I'm getting exactly 2 hits that I have to write in numerator. Okay, now we can simplify this one. That is 2 goes into 2 1 times and 2 goes into 8 4 times. So that is 1 over 4. So the probability of getting 2 hits is 1/4 when a coin is tossed 3 times. Now let's answer the second question. That is, we have to get probability for at least 2 hits. Let's say this is event B. Then the probability of getting even B equals to. So the same formula, we have to write the total number of all possible outcomes in denominator. Now for this one, we have to count the number of outcomes. That is for at least 2 hits. At least 2 hits means minimum 2 hits. Okay, here in this one, this one, this one, there are 2 outcomes, and also we have to include this one. There are 3 outcomes. So we have to count the number of outcomes where we get a minimum 2 hits. So there are 4 outcomes in which I am getting at least 2 hits. So we have to write that 4 in numerator. So here 4 goes into 4 1 times and 4 goes into 8 2 times. I am getting 1 over 2. So when a coin is tossed 3 times, the probability of getting at least 2 hits is 1 over 2. Here we have the next problem. Let me go over the question. A die is rolled twice. What is the probability of getting a difference of 2 points? Did we know that when a die is rolled, there are 6 possible outcomes, the numbers from 1 to 6. Okay, when a die is rolled twice, then we have to take these 2 as an exponent for this one. Then 6 square equals to 6 times 6, that is 36. When a die is rolled twice, there are 36 possible outcomes. Okay, now to get the probability of getting a difference of 2 points, that is for this event to get probability, first we have to write all the 36 possible outcomes. Okay, now let me write it over here. Here I have written all the 36 possible outcomes when a die is rolled twice. Okay, let's understand the outcomes over here. Let me consider the first outcome 1, 1. That is first time I'm getting 1. The second time when I roll the die, again I'm getting 1. Or first time I may get 1, second time I may get number 2. First time getting 1, I am getting 3 in the second time. The same thing we can consider for each outcome. For example, let me consider this one. The first time when I roll the die, I am getting the number 5. Second time I am getting 3. So in this way, we are getting 36, the total number of possible outcomes when a die is rolled twice. Okay, now we have to find probability for getting a difference of 2 points. Let me assume A is the event of getting a difference of 2 points. So we have to find probability for the event A. According to the formula, we have to write the total number of all possible outcomes in denominator, that is 36. Now to get the value for numerator here, we have to count the number of outcomes where we get the difference of 2 points. Okay, in the first row, this is the outcome. We get the difference of 2 points because the difference between 1 and 3 is 2. Okay, in the second row, 2, 4. The difference between 2 and 4 is 2. In the third row, we have 3, 5 and also 3, 1. There are 2 outcomes in the third row. We get a difference of 2 points. In the fourth row, we get 4, 2 and also 4, 6. There are 2 outcomes. In the fifth row, we get 5, 3. So there is only one outcome where we get difference of 2 points. In the last row, so here we get 6, 4. Okay, now we have 8 outcomes where we get a difference of 2 points. We have to write 8 in numerator. Okay, now what is the greatest common divisor for 8 and 36? That is 4. That is 4 goes into 8 2 times and 4 goes into 36 9 times. So 2 over 9. So when a die is rolled twice, the probability of getting a difference of 2 points is 2 over 9. Here we have the next problem. Okay, let me go over the question. 2 dice are rolled once. Find the probability that the sum of points on the 2 dice would be 7 or more. Okay, the same thing what we have discussed in the previous question. When a die is rolled once, we know that there are 6 possible outcomes. When 2 dice are rolled once, we have to take these 2 as the exponent for 6. Then we have 36 outcomes. Already we have written over here. And when I understand the outcomes over here, let me consider the first outcome. So that is, in the first day, I'm getting the number 1. The second day also, I'm getting number 1. Or I get 1 in the first day. I may get 2 in the second day, 1 in the first day, 3 in the second day. In this way, we get 36 possible outcomes. Okay, now let's consider that is getting the sum of points on the 2 dice would be 7 or more as event A. So then we have to get probability for the event A, and in denominator we have to write the total number of all possible outcomes, and that is 36. Now to get the number in numerator, we have to count the outcomes over here where we get the sum of the 2 points as 7 or more. Okay, now let's go to the first row. There is only one outcome where we get the sum of the 2 points as 7. There is 1 past 6 is 7. And in the second row, we get two outcomes where we get the 7 or more. In this outcome 2, 5, the sum is 7. In this one, 2 positive 6 is 8. That is more than 7. And in the third row, we have 3 outcomes. In the fourth row, we have 4 outcomes. In the next row, we have 5 outcomes. In the next row, we have to consider all the outcomes, because in all the outcomes, we get the sum of the 2 points, 7 or more. Okay, here we get one outcome over here, 2, 3, 4, 5, 6. Okay, 5 positive 6 is 11, 11 positive 4, 15, 18, 20, 21. There are 21 outcomes where we get the sum of 2 points, 7 or more. So we have to write 21 in numerator. Okay, the greatest common divisor for 21 and 36 is 3. That is 3 goes into 21 7 times and 3 goes into 36 12 times. Okay, we get 7 over 12. Okay, when 2 dice are rolled once, the probability for the sum of the points on the 2 dice would be 7 or more is 7 over 12. Here we have the next problem. What is the chance of picking a spade or an ace not of spade from a pack of 52 cards? Okay, here we have all the 52 cards over here, and we have to find a chance. Chance means probability of picking a spade card or an ace not of spade from a pack of 52 cards. Okay, this question is little tricky. Now we have to assign two events. One is for picking a spade card, and other one is for an ace not of spade. Okay, now let me say A is the event of picking a spade card, and B is the event of getting an ace not of spade. And to answer this question, which contains R, we have to use addition theorem of probability. That is P of A or B. Or instead of R, we can use the word union, P of A union B, because union and R, both of them are same. So the formula is P of A positive, P of B negative, P of A intersection B. Okay, for P of A, the formula is N of A over N of S. And for P of B, we have the formula N of B over N of S. And for P of A intersection B, we have to write N of A intersection B over N of S. Again, I just used the classical definition formula. That is, N of S represents the total number of all possible outcomes. That is the number of elements in the set sample space. And here N of A means the number of favorable outcomes for the event A. The same thing we have for this one and this one as well. Okay, now we have to get N of A. N of A means for the event A, we have to find the number of favorable outcomes. So there is picking a spade card. How many spade cards are in all? So there are 13 spade cards over here in the third row, 13 black cards over here. So for event A, we have 13 outcomes. So the number of favorable outcomes for event A is 13, and N of S is the total number of all possible outcomes. So that is 52 cards. Let me write over here. And N of B, we know that the event B represents an ace not of spade. So we have to consider the ace cards, but it should not be spade. Then we have to consider this one, this one, this one. We should not consider this ace because it's a spade. So we have to consider the ace not of spade. There are 3 outcomes for the event B. So 3 over 52. Okay, now A intersection B. A intersection B means we have to find the common element for the 2 events A and B. So common means we have to pick the card which is a spade, and also an A is not a spade, but that's not possible because here we have to consider the cards which are not of spade. But here we consider only the spade cards. There is no chance to get the common card for A and B. So it's actually disjoint sets. A and B are disjoint sets. So the N of A intersection B is 0. So then 0 divided by 52 is 0. Okay, now we had 2 fractions with the same denominator. So we can take 52 as a common denominator. Then we have to add the numerators. So 13 positive 3, that is equal to 16 over 52. The greatest common divisor for 16 and 52 is 4. That is 4 goes into 16 4 times, and 4 goes into 52 13 times. We get 4 over 13. So that is the chance of picking a spade or an ace not of spade from a pack of 52 cards is 4 over 13. Here we have the next problem. Okay, let's go to the question. Find the probability that a 4-digit number comprising the digits 2, 5, 6 and 7 would be divisible by 4. No digit should be repeated in any number. That is, we have to form a 4-digit number using the digits given over here. When I do so, no digit should be repeated in any number. Okay, now let me create 4 blanks over here. 1, 2, 3, 4. The blank over here represents ones place, and this one represents tens place. Here we have hundreds place. Here we have thousands place. Okay, let me consider the digit 2 in thousands place. Okay, we have used the digit 2 in thousands place. Again, the same digit should not be repeated in any of the remaining 3 places. For the remaining 3 places, we can consider the other digits, like we can consider the digit 7 in hundreds place, and 6 in tens place, and 5 in ones place. Here, no digit is repeated in any number. So this is what is meant by this statement over here. Okay, now first we have to find how many 4-digit numbers can be formed using the given digits over here. So that is the total number of all possible outcomes in this experiment. So in the probability formula that we have to write in denominator. How do you have to get the total number of all 4-digit numbers which consists of the given digits over here, with the condition there is no digits should be repeated in any number. Okay, in thousands place, how many options we have? We have 4 options. That is, we can fill one of these 4 digits. So let me write 4 over here. Even though we have 4 options for the thousands place, only one of these 4 digits can be filled over here. And for this one, we have the remaining 3 digits. So we have 3 options for this one, because the digit which has been used over here in thousands place cannot be considered for this place, because no digit should be repeated in any number. So for thousands place, we have 4 options. That is, we can use one of these 4 digits. So we write 4 over here, and one of the digits is filled over here, and we have 3 remaining digits. So one of those 3 remaining digits can be filled in 100th place. Now we have used 2 digits. Now we are left with 2 digits. So we have 2 options for tens place. Okay, one of them is filled over here. Now we have only one left that can be filled at the ones place. Now let's multiply this 4, 3, 2 and 1. What do we get? 4 times 2 is 12, 12 times 2 is 24, 24 times 1 is 24. So we can form 24 4-digit numbers using the given digits. In all the 24 4-digit numbers, no digit will be repeated. So the total number of all possible outcomes in this experiment is 24, and let A be the event of getting a 4-digit number which is divisible by 4. So we have to find the probability for the event A. So in denominator we have to write the total number of all possible outcomes, so that is 24. 24 4-digit numbers which can be formed with the digits over here. Okay, in numerator, what numbers should we write? So we have to find the number of 4-digit numbers in these 24 numbers which are divisible by 4. Okay, here all the 24 numbers are not displayed like what we have done in the previous problems. Okay, if you are able to display all the 24 4-digit numbers, we can get the numbers which are divisible by 4. But it's a long process. It's not possible. Okay, there is an idea for that. Okay, let's understand how to check whether a number is divisible by 4 or not. Let me write a number over here, that is 29432. Okay, here I have done a number that is on 29,432. I want to check whether this number is divisible by 4 or not. For that, we have to consider the number formed by the last 2 digits. That is a digit in the tens place and the digit in the ones place. So the number formed over here is 32. This 32 is divisible by 4 or not? Yes, it is divisible by 4. So when the number formed by the last 2 digits is divisible by 4, then the complete number is divisible by 4. Otherwise, the last 2 digits must be 0. Then this number is divisible by 4. But in our problem, there is no chance to get 2 zeros at the end. Okay, now let me take 4 blanks over here. 1, 2, 3, 4. And let me write the given digits 2, 5, 6, 7. Okay, let me take the first digit. It has to be paired with 5, 6 and 7. When it is paired with 5, I am getting 25. So here the number formed by the last 2 digits is 25. So 25 is divisible by 4? No, it's not. Now let's pair 2 with 6. Then we get 26. 26 is divisible by 4? No, it's not. Let's pair 2 and 7. We get 27. 27 is not divisible by 4. Now let me take the second digit 5. It has to be paired with 2. Then we get 52. So 52 is divisible by 4 or not? Yes, it is divisible by 4. Okay, now let's lock these 2 places. Okay, here we have taken the digits 2 and 5 over here in the last 2 places. Now, how many options do we have for the first place? We have 2 options, 6 and 7. So let's write 2 over here. Please remember, this 2 does not represent the digit. Number of options available for this thousands place. And so we have two options for this place, but one of them will be used. We have only one option left for the next place. So now let's multiply the number of options over here and here. 2 times 1 is 2. So we are able to get two 4-digit numbers which are divisible by 4, where those two 4-digit numbers end up with 52. Now again create 4 blanks over here. Okay, already we have paired 5 and 2. Now let's pair 5 and 6. That is, we get 56. Okay, so here we got a number 56. 56 is divisible by 4 or not? Yes, it is. So let's lock these two places. Now, how many options do we have for the first place? So we have taken 5 and 6. We have two options. And one of them will be used over here. And the remaining one we have for this place. So now let's multiply the number of options over here and here. So 2 times 1 is 2. Okay, here we get two 4-digit numbers which are divisible by 4. Those two 4-digit numbers end up with 56. Now let me create again 4 blanks over here. Already we have paired 5 to this 2 and also 6. Now let's pair this 5 to this 7. Then I'm getting 57. 57 is divisible by 4 or not? No, it's not. Okay, now let's consider the digit 6. Let's pair this 6 with 2. 62 is not divisible by 4. Let's pair 6 and 5. 65 is also not divisible by 4. 67, no, it's not. Now let's take 7. 7 has to be paired with 2. Then we get 72. So 72 is divisible by 2 or not? Yes, it is. So let's log these two places. And we have used 2 and 7 in the last two blanks over here. So now for this blank, we have two options of 5 and 6. And we just use one of them over here, and we have only one option over here. So now let's multiply the number of options. 2 times 1 is 2. Okay, here I get two 4-digit numbers which are divisible by 4. Those two 4-digit numbers end up with 7 and 2. Now let me create another 4 blanks over here. Okay, now let's pair with 75. No, 75 will not work because 75 is not divisible by 4. What about 76? Yeah, 76 is divisible by 4. Let me write 7 and 6 over here. Here the number formed by the last two digits is divisible by 4. Let's lock these two places. And the same thing. So for 1000 place we have two options, and for this one we have one option. 2 times 1 is 2. So here I got two 4-digit numbers which are divisible by 4. Those two 4-digit numbers end up with 7 and 6. Okay, in this way, I am getting 8 4-digit numbers which are divisible by 4. So out of the 24 4-digit numbers formed using these 4 digits, 8 4-digit numbers are divisible by 4. That 8 should be written over here in numerator. 8 goes into 8 one times and 8 goes into 24 3 times. We get 1 over 3. So when a 4-digit number is formed with the digits 2, 5, 6 and 7, the probability of getting a number which is divisible by 4 is 1 over 3. Hello students, hope you have understood all the stuff which has been explained so far on probability. For more math content, keep watching our YouTube channel. Thank you.